Exploring computer innovation, one of the big questions here is how can we make computers to be faster and much more efficient in its function? And one of it all comes down to the chips that are being used in order for we to speed up these processes. Now, the chips that we know of, like in our cars, electrically speaking, but also computers, laptops, they all function on the basis of silicon, and silicon is really widely popular all around the world in terms of this fundamental material that helps in here to foster this incredible work that computers have to undergo. Now, silicon we know here is made out of silicon itself, or we can say that it is known to be a semiconductor. And semiconductors, in this case for silicon, they are really good electrical conductors, and also in this case here they are really quite effective in terms of the processing of information. Now, in here, according to this new research here team, they created a working and scalable semiconductor from what? Graphene. And graphene here is really known to be a new technology or material that is, of course, one made out of a lot of carbon atoms that are at a specific single layer. And these single layer carbon atoms, they are really stronger than what steel in terms of that of its comparability with its thickness is known to be a really extremely good conductor of electricity, and it is highly resistant to heat and acids. So that right there is really a big plus here, because of course one, when we got acid rain or is exposed to a lot of heat, this here is pretty much a great deal in terms of the fans. If you improve the fan quality of your computer, it will not make any difference. Well, it depends on the limit of that particular graphene, but it's highly conductive of electricity and is resistant to heat. So that is really good plus here in terms of the use of these in computers. Now, this here is, despite its advantages that is listed right above here, a working graphene semiconductor which can be controlled to conduct or insulate electricity at will has endured scientists until now. And such semiconductors are key to creating a logic chips that powers computers. Well, when we say logic chips, just think of it as the brain of the computer, pretty much just saying the CPU, central processing unit. Now, one of the key points to keep in mind are the potential problems here that we should be aware of. And one of these problems have to do with band gaps that are really popular in semiconductors. And you might be wondering, what are band gaps? These are pretty much high energies here and low energies. And these are really populated by electrons, where when they are excited, they hop to a higher energy, which causes a on, or I would say easy flow of current, or a drop, which is a turning off of that particular current flow. This here is the basis for digital computing, and in terms of how it functions, is basically knowing how binary system works, where you switch on, pretty much you have current flowing, and that is going to be associated with the binary system, one of the components to be 1. But when it is switched off, it's like you don't have any current flow, which is not conductive, and therefore this here is associated with the binary component, which is 0. So this is how it works here, basically. And so this here is really one of the big questions that we need to dive into when it comes to semiconductors, and how close this gap is, so that it's easy for the electrons to move from a lower energy to the higher energy and hopping back and forth. So this here is one of the key points to keep in mind in terms of one of the problems that they might approach this particular innovation on this particular material here. Now, previous research have shown that graphene can really act as a really good semiconductor on a small scale, but when we scale this up to a much more bigger scale, there are a lot of obstacles that actually come into play in terms of the creation of holes, which may be unusual effects of electric flow, and creating a possibility for the logical chips that could be made by creating a right landscape of flaws in this particular article coded right here. Now, one big advantage that silicon have over graphene is how this silicon here is known to be really cheap, and it is really backed by a lot of huge industrial manufacturers. Now this here can lead to limitations, of course, in terms of the demand of this and how much we have in here. And so these are questions that's going to be coming up in the future as we are becoming more digital in this particular system in terms of automating cars, also various devices that we are having now. How much of this is going to be sustainable, and how much of this limitation is going to be fostered or be revealed here? And this is where an alternative here will be a great bet here for, in this case, graphene to come into the market. But here in this case right now it's at its infant stage, and which means that of course it's going to be more expensive. There'll be a lot of huge innovation that's going to be poured into this, and how much investors is going to be able to put in their chips into this particular technology will actually make a huge role in terms of how this diversity, or opening the doors to diverse materials to be researched on based on this little gate that is open here. So really interesting to think about something like this based on the future of chips creation or generation based on all these interesting fundamental materials. Or just looking across the periodic table, there might be other elements that are at a particular ladder, and those ladders are pretty much semiconductors, so they could try others out there. Some of them might be rare, some of them might be naturally abundantly occurring, so there'll be a lot of deep research that have to go into this, or maybe some other allotropes of those elements. So it could be interesting to see how this plays out down the road here. Now here are 5 summary points to take away from this article here. One is that the article reports on a new way to create graphenes with a band gap, which is essential for making transistors and other electronic devices like electric cars, which is really going to be a huge blow up here in the future. And also in terms of locations where this can be created, which is much more effective compared to that of silicon, which has to be outsourced from various parts of the world. So in here, next point here is that the researchers used silicon carbide wafer that were heated to evaporate the silicon and leave a layer of graphene on top. And so this here is a way to create graphene from silicon, and this is really a huge accomplishment here because of how this can be a nice duality in terms of how silicon can be used for transistor, or in this case chips, but also if you want to recycle it, it can be another way to recycle it into a much more effective one, like hopefully graphene. So another point that is made here is that researchers, they claimed that the electrical properties of graphene semiconductors were far better than those of silicon chips, and this here comparing them to driving on a freeway versus on gravel roads. Now another point here that has been made by this article is that the use of wafers is important because it makes the process scalable and compatible with existing silicon semiconductors manufacturing infrastructure. Now, side note on what wafers are, in this case they are a piece of silicon that is, or other semiconductors, in this case it could be graphene, and this here forms a very thin disk. And in addition to this, or comparing it to what chips are also commonly known as an integrated circuit, and it is the assembling of hundreds of millions of transistors on a small form factor chip, of which size depended on the type of integrated circuit. Now a wafer is the base of any integrated circuit which is made of silicon, or in this case graphene here. And final point here based on this article acknowledges is that the challenges and skepticism that graphene faces in replacing silicon, which has a huge advantage in terms of the development and performance, is really something to watch out for here now and in the future. And yes, there have been a lot of competing materials before graphene showed up, and silicon has been a dominant player in terms of material used to create chips. And so will graphene be an incredible alternative here in terms of this great advantage that it's providing here compared to that of silicon? Or do you think that not really, let's just stick with silicon because this here is a technology that we're familiar with, we're not really familiar enough with that of graphene? But take note here that graphene is a huge conductor of heat, so it can take in as much heat as possible, but we don't know too much about that compared to silicon. So I hope you found this informative in terms of the potential here for graphene, in terms of how it's going to explode everywhere, in terms of the production of chips and improve the speed and quality of computing in our future exploration here of, I say, of technology or science. So drop down into the comment section and let me know your thought about this. All the same, stay smart as always and believe in yourselves.